Welcome everybody to today's Tech Talk. My name is Brian Ashley, and today we'll be talking about how Aviatrix is helping health and life sciences customers in their cloud journey. With me today is Mac Tate, who is a customer solutions architect here at Aviatrix, who focuses in on some of our HLS customers. Today we'll be talking a little bit about the Aviatrix solution as a quick overview for those who may be new to the platform, but then specifically focusing on some of the challenges that HLS organizations face on their cloud journey, how Aviatrix helps with some of those challenges, and then we'll dive into a customer example, as well as show a quick product demo. Before we get started, if there are any questions, please use the Q&A section at the bottom of the portal. We will try to answer those live at the end, but we will also try to answer as we go. Next slide, please. Great, so just to get started and baseline who Aviatrix is and what we do, Aviatrix is a cloud networking and network security platform that exists inside of the CSPs today. So we often get compared or confused with some other cloud connectivity solutions, such as SD-WAN or private connectivity providers like an Equinix, a PurePort, or a Megaport, as well as some SASE solutions. So Aviatrix has integrations with all of those players. However, those players tend to focus on connecting to the cloud. They will do so in intelligent ways and low latency ways. However, their capabilities tend to stop at the cloud edge. What Aviatrix really does is provides a repeatable architecture inside of the cloud, orchestrate some of the native constructs to build a repeatable architecture that you can expand and leverage all CSPs with. So that while Aviatrix does have integrations into some of these partners and players, where Aviatrix really exists is inside of the networking data planes in the clouds themselves. Next slide, please. So Aviatrix starts with that common architecture, which we refer to as MCNA. MCNA is a multi-cloud network architecture, but the idea is Aviatrix wants to bring the enterprise class visibility and control that we're used to in the on-prem world. So we do that consistently across all of the major cloud providers and then insert security and operations throughout that environment. So organizations have a repeatable architecture that they can leverage. They can use the best of what's in cloud, and then we can start to augment those services where some of the CSPs may fall a little short with advanced services. Next slide, please. So it all fundamentally starts with cloud transit. That's depending upon the different CSPs, there may be a native solution that provides transit capabilities within the cloud, but that tends to only exist within a specific CSP. As you need to expand or migrate or support another CSP, that's a different type of architecture and different type of underlying mechanisms that provide transit. This presents a challenge to a lot of enterprises because now the architecture becomes inconsistent. We don't have the same repeatable mechanism across these cloud providers. So what Aviatrix tries to do is build an architecture that provides a repeatable transit mechanism within clouds and across clouds. And then on top of that, next slide, please, starts to layer in some advanced services around networking and security and day two operations and visibility. So whether we're talking about being able to handle things like IP address overlap or really starting to bring some common troubleshooting tools that we're used to in the on-prem world, like ping and traceroute and packet captures, Aviatrix will layer those in granularly to augment and extend a lot of the native cloud constructs. So from a platform perspective, Aviatrix is able to take what's best in cloud, orchestrate away some of the cloud complexity that exists in particular clouds, do all of that in a repeatable way, and then start to layer in some of these advanced services where those cloud constructs may fall a little bit short. Next slide, please. So that's a very quick overview of Aviatrix and the Aviatrix platform as a whole. But in this particular Tech Talk, what we want to do is focus in on health and life sciences. What are the challenges some of those organizations face when they're coming to cloud, and how Aviatrix is really helping those customers on their cloud journey. So HLS is a very interesting vertical right now, and really ripe for disruption, quite frankly. The HLS industry, whether it's comprised of payer and provider, or the healthcare providers themselves, or things like supply chain issues, right, have historically been bogged down with a lot of manual legacy systems. And the promise of cloud is access to things like high performance and compute and machine learning and all of these new innovative ways that really allow HLS organizations to leapfrog some of their competitors, but also start to solve some big challenges that we've been faced with. One of the most recent example, obviously, is COVID, and which has forced really the HLS industry as a whole to look at things in a very different way. Whether it's providing care to patients who are now remote, whether it's being able to deal with situations like the IOMT, Internet of Medical Things, or connected drug delivery devices. The HLS industry has this opportunity to really change the game and really be innovative in the services that they're providing if they can start to leverage some of these cloud technologies. But the challenge is how do they get there, right? So there are many organizations that have a very, very small IT staff, and they have to figure out how do they get into cloud? How do they take advantage of these new and innovative tools when the cloud represents a whole new learning curve that has to happen, not only with one cloud, but multiple clouds. Then there's also getting data, legacy data, which may be in distributed clinics or in on-prem systems, into the cloud, but also being able to facilitate connectivity of data, which is now more disparate, right? We've got this sort of ubiquitous consumer payer provider presence where the external parties can be anywhere. They can be remote, as we mentioned, due to COVID. They can also be in other clouds. The way that people are interacting with these HLS systems is very, very different than it was in the on-prem world. In addition to that, many of the decisions that are being made for sort of the future of HLS companies are happening at a high executive level. As an example, a research and development firm may decide that they want to take advantage of machine learning that exists in Google, but the backend database is in Oracle, right? Or for a payer provider type system, maybe the front end of that is an application that exists in AWS, but the backend is living in Azure in a SQL database. So that high level initiative gets pushed down, and the enterprise IT organization, which, like unfortunately most organizations, is a small team that has to figure out how to make this work and make all of this technically feasible. So it presents a real challenge for HLS organizations, one, in just getting to cloud, understanding how cloud works, how multi-cloud works. But then we also have to layer in the fact that much of this data is highly sensitive. We're talking about EMR data that, one, needs to be fully protected no matter where it exists, but now it is being asked to exist everywhere, whether it's from those connected devices, whether it's in another cloud to leverage machine learning. It all has to be encrypted from end to end in a complete and holistic way. Lastly, one of the big things is business criticality. Now, of course, every vertical on the planet cares about their applications being highly available and resilient. Now, the reality is, for most organizations, they may lose money, it may be a huge inconvenience, and people may be upset. But with the HLS industry, we are very often talking about life-saving activities, right? If we have availability issues with connected drug delivery devices, as an example, or in the case of remote patient care, if we have availability issues, we are very, very much talking about people's lives and their health. So it's just a whole different level of business continuity and disaster recovery. So while all this expanse is happening and all of these new sort of tools that are available are trying to be leveraged, it is very, very critical that all of these applications stay redundant and resilient. So these are all challenges that, while there's so much promise for the HLS verticals and industries and being able to take advantage of cloud solutions, these are some of the major challenges that they have to overcome in order to get there. And oftentimes it comes down to the IT infrastructure teams and the operations folks to figure out how to make that happen. How do we stitch all this together so that our business can really thrive and have the opportunity to take advantage of all of the cloud offerings and really accelerate the service delivery, but do all of that in a resilient and operationalized way. Next slide, please. So how does Aviatrix help with all of this, right? So at the end of the day, and at the beginning of this Tech Talk, we talked about how Aviatrix is a network and network security platform for the clouds, right? So what is it that Aviatrix does inside of its platform that starts to help some of those critical points that we just talked about, whether it's disaster recovery, whether it's the ability to handle some of the multi-cloud components, or be able to handle sort of that ubiquity of where the ubiquitous presence of where our consumers, the people using these HLS systems reside, right? Whether they're in another cloud, whether they're at their homes, whether they're in hospitals. How does Aviatrix help with all that? So at its core, right, again, what Aviatrix does is start to provide optionality across the CSPs. So as organizations are looking to go into cloud, Aviatrix normalizes the network and network security within that cloud environment. So said another way, what Aviatrix is doing is shortening that learning curve. So rather than a team having to be experts in a particular cloud, whether it's AWS, Azure, GCP, OCI, Aviatrix can abstract away a lot of that complexity, and it can do so in a very repeatable fashion. So now that helps with an initial migration to that respective cloud, but also when the scenario comes up where we need to expand to another cloud, whether it's to leverage some other cloud construct like the machine learning and GCP, or if we have to facilitate consumers accessing our applications from another cloud, right? Maybe we need some presence in OCI, or maybe we need presence in AWS because a partner or a facility has presence there, and that's how they would like to consume our service. Now we have the challenge of historically of learning another set of tools and rules and constructs from that other CSP. But with Aviatrix, it's a seamless extension of the exact same architecture, capabilities, and footprint that we had in our initial cloud. We don't have that learning curve. We can extend seamlessly over to that other cloud to establish that presence and provide that level of connectivity without having to uplift our entire organization, whether it's the architects or whether it's our day two operations and visibility folks. Another item is we talked quite a bit about the security aspect, where how this EMR data, which is highly sensitive, needs to be secured both in the cloud as it gets migrated up, but then also as access to that data gets proliferated out to the edge as we're doing things like remote healthcare or connected devices for IoMT or Internet of Medical Things. We need to make sure that end to end, no matter where that presence exists, that our EMR data or our HLS data is secured. So Aviatrix as a platform provides encrypted transport by default. So what that really means is by leveraging Aviatrix, Aviatrix becomes the data plane of your network, not only in the cloud, but also extending down into either on-prem or IoT devices or connected facilities that are connecting to cloud. And by extending that data plane all the way through and having one centralized data plane and common control plane, Aviatrix has the ability to ensure that all of that is encrypted from end to end. So even as traffic is coming from a connected branch into one particular cloud, say AWS as an example, to hit a front end, which is then leveraging some machine learning and GCP, Aviatrix provides that entire data plane. So all of the data that's traversing that path is fully encrypted, and it's encrypted at line rate. So there's no sacrifice to performance, but Aviatrix provides that level of security holistically across the footprint, no matter where that footprint expands to. The last one, final piece that I want to talk about is the redundancy aspects. Again, while every vertical talks about the need for being able to provide high availability and redundancy, even the CSPs do this themselves through the concept of availability zones. Some, like Azure as an example, has other constructs like availability sets. But there's still, again, a different level of availability when we talk about the HLS industry. The reality is, just by the services being provided here, that there's a different level of criticality when it comes to availability. So one of the really nice things about Aviatrix is to be able to leverage what's native about cloud and those cloud constructs, but then layer in these overlay technologies and these advanced services to extend the functionality of that, right? Where those may fall a little bit short, Aviatrix can leverage them, but then layer in these advanced services where we need to. Now, what does that really mean for availability, right? So the reality is what Aviatrix is doing is treating everything that exists in the CSPs as a mechanism available to the platform. So we are able to use the paths that are provided from a connectivity perspective that the CSPs give us, or that the private connectivity providers like Equinix and Megaport, or the SD-WAN solutions, we're able to leverage the paths that they make available. However, if those paths fail, Aviatrix can start to granularly insert some of the redundancy capabilities that may not exist with those native constructs. So a lot of times when we look at like some of the private connectivity mechanisms that AWS or Azure provide, right, there are limits in what we can do from a failover perspective. We have some dynamic routing capabilities and things like that, but when we talk about being able to leverage multiple paths, say going through one cloud provider to get back to another, those are capabilities that we don't have natively, simply because the CSP that is providing that connectivity doesn't have visibility into the whole footprint. Azure doesn't know about your AWS connectivity and vice versa, right? They're completely separate control planes that are unaware of each other. Aviatrix unifies all of that. And so it operates at a higher level that has visibility into your entire multi-cloud footprint. So that when something fails, say, again, just using that example, an Azure Express Route circuit fails, and we need to leverage a path that is outside of Azure to get back to those Azure resources, Aviatrix is able to leverage its advanced services to do just that. So from that centralized control plane that has visibility over the entire multi-cloud footprint, we can reach into that data plane and make the appropriate updates to redirect traffic through another cloud, in this case AWS, over a direct connect circuit to get back to Azure. Right now, again, yes, we may experience some additional latency and things like that as a result of that longer redundant path. But in the case of an industry like health and life services, where outages, can have serious implications, that's a level of redundancy and resiliency that you need, right? So that as you're troubleshooting issues and outages, you still are able to maintain connectivity and availability of the services that you're providing. Now, that becomes even more appealing when we look at things from an IoMT type perspective, right? Or those connected devices or IoT devices that are out in hospitals and things like that. As you think about the application of the Aviatrix platform and being able to leverage those advanced services, especially in those use cases, the capability to be able to ensure that you have this always on connectivity, granted, during disaster scenarios where things may take a longer path, they're still connected. And so you're still able to provide the services to your remote patients or your EMR platforms, payer provider platforms, to ensure that the business is still operational. The reality is, with all the good that cloud provides, there are still outages. And this isn't picking on a particular CSP. This happens across CSPs. And unfortunately, it happens quite a bit. And so organizations that rely on this, or have these critical applications, have to find ways to be able to work around that. And oftentimes it's not as simple as just having an active or standby environment that can be spun up in Cloud B. We need things to be active, and we need the intelligence to be able to work around these localized outages as they happen. Do so in a real way and ensure that when we do that, we're not losing any functionality. We're not putting anything at risk from a security perspective, or being able to have to depend on a different type of architecture or connectivity mechanism. One last little piece that I wanted to talk about before I turn it over to Mac and have him walk us through some customer examples in a demo is another feature that the Aviatrix platform provides through some of the advanced security functionality. So as I mentioned before, the Aviatrix platform provides this data plane that is consistent across all of the cloud providers, as well as extends down into those connected devices, whether it's branches or data centers or hospitals, hotels, or IoT devices. So again, one of the things that we talked about was that the security of this EMR data is so critical, right? We need to make sure that things are encrypted all the time. But one of the things that we're seeing in the news quite a bit, unfortunately, is ransomware attacks and security vulnerabilities that are happening all the time, which again is another huge concern for a lot of HLS industries. If there's any sort of susceptibility there, right? Obviously, it's a hit to customer confidence, which is a hit to the business, but there also can be serious repercussions to the consumers based on the life-saving treatments that may be being provided. So one of the unique things about Aviatrix, because it acts as that underlying data plane for everything, is it has the ability to layer in security in a very unique way. So as the traffic is traversing the Aviatrix platform, security inspection is able to be done throughout the entire network platform. So at each hop within the network, we're able to add some level of security inspection. Now in Aviatrix, we call this ThreatIQ. What we're able to do is look at all the traffic as it traverses the network and compare it to well-known bad actors, malicious actors, right, that exist out on the internet. And if we see activity or data being sent to those bad actors, we can then automatically remediate that. That's optional, but the platform has the capability to automatically remediate that behavior by pushing down stateful firewall policies across the entire multi-cloud footprint. So as an example, let's say that through an HLS environment, we're starting to notice that critical data is being sent to a well-known bad actor out on the internet. The Aviatrix platform, all contained within the customer's tenant, will be able to recognize that and recognize that data is being sent out. And if enabled, will automatically push a firewall policy down all the way to the workload to be able to block that activity going out. So it's just, and you could start to see the power that Aviatrix has by owning that data plane and providing that services, is being able to then inject security throughout all of those hops across the network. So rather than bolting on security as an add-on to your environment, it is now embedded in the entire network footprint across the multi-cloud. So it becomes very, very powerful as the central control plane and this distributed data plane start to embed security throughout that entire platform, not only to encrypt sensitive data, but also to take action if we start to see malicious behavior that's happening and protect the environment as a whole. Okay, so with that, what I'll do is I'll turn it over to Mac so he can take us through a customer example as well as a quick demo. Mac?
Thank you, Brian. So today we're going to talk about a real world example of how Aviatrix helped a customer develop a cutting edge treatment and how we improved their research, clinical trials, and go-to-market times with the Aviatrix suite of products. While this customer use case is real, we use a fake research and pharmaceutical company named Ace Cloud Research Company, or ACR for short. ACR approached Aviatrix with a need to develop participant data for a new treatment at a very large scale. In the traditional world, you would have your data center and specific locations spread out geographically, and you'd be able to ingest some data from certain locations and work with certain facilities, but a large scale could present a problem. This is where the cloud and the CSP capabilities really are attractive to a lot of HLS organizations. ACR wanted to partner with leading hospitals, universities, and nonprofit organizations all across the world to gather real world data and obtain regulatory approval for multiple governments as quickly as possible. To accomplish this, they decided to build an application in the cloud. However, they needed to ingest participant data from multiple different sources. As you can imagine, the ways of collecting participant data varies across the organizations, and there were many different participants in this study. So some participants had sophisticated EMR systems. Some participants had remote locations that utilize spreadsheets or non-traditional applications, but there needed to be a way to ingest all of this data and continue to meet the security and regulatory requirements for each of the participants. Also a key challenge was that there were some places where the data ingestion could not occur outside of the host country, so they had to be able to work with a CSP that may not have been their primary partner or one that they were familiar with. ACR needed a repeatable architecture that could be spun up in a CSP of ACR's choosing and provide some level of visibility and consistency no matter what cloud was chosen. Aviatrix was able to provide ACR with multi-cloud networking architecture that they desired and allowed them to ingest all of the data while providing end-to-end security for the application. When you're dealing with a lot of these customers and a lot of your own personal ingestion of data, sometimes that data can be something small like spreadsheets, text files, things of that nature. In other cases, with those sophisticated EMR systems, you may have a large database that's being pushed to you. From a research perspective, you have to be able to ingest all of that data, and at the same time, as Brian mentioned, you need to have security and protection around that data, but sometimes the native application may not provide that to you. That's where Aviatrix comes in with our end-to-end security features. So looking at some of the requirements, as we discussed, some of the data may or may not support encryption. However, it is required. We are required to comply with regulations such as HIPAA, GDPR, the California Consumer Protection Act, as well as, and I'm probably going to butcher it, please forgive me, the PIPE-DA, the Canadian Consumer Protection regulation as well. Most of those regulations require security in transit. At the same time, we also want to provide inspection as the traffic moves through the cloud, and to be able to give you that enterprise level visibility and auditing that you are used to in an on-prem world. We were asked to provide the ability to connect to a remote site of any type, whether that is a Cisco firewall or a Cisco router, a Linux host, Juniper firewall, etc. They were asking to have the ability to leverage any type of customer that needs to come to them and provide data. So we were able to provide that for them. In addition, a very common issue is overlapping IP space between different customers and different providers of data. With that, we do support multiple features to allow you to use a source or destination NATing. In addition to that, we were asked to provide the ability to isolate this specific application from other data streams inside of their CSP. One example would be, and we'll show this in a diagram here in a moment, but one example would be this customer application data or this participant application data separate from a traditional PACS system where you have imaging data. We have the capability of not only providing inspection and auditing, but we also can segment data from one CSP or even one VPC to another. In addition to this, we needed to work with the native CSP constructs, such as the network load balancing, web application firewall, and application load balancing. As they were building the application, they started building the application with these native CSP constructs. And like many companies, they realized that they needed some assistance moving the data throughout the cloud. And that's where we came in. So without having to rebuild the application, they wanted us to connect into the application and provide the data to them. And we were able to do that successfully. In addition, they were currently using a Palo Alto network based firewall. They wanted us to be able to integrate with that Palo Alto and provide them the traditional enterprise visibility that Palo Alto will give you. So we were able to tie in with their existing firewall, but in addition, we can work with Checkpoint and Fortinet. And as Brian mentioned earlier, they were very concerned with attempted bad actors accessing the data, both inbound from an ingestion perspective, as well as the application trying to communicate outbound. And we're able to provide that visibility using ThreatIQ. So looking at this diagram, starting here on the left and moving left to right, we have here on the left the hospital, university, and research facilities. They needed a way to connect into the cloud securely to transmit the data in a secure fashion. So what we did here was we set up a remote edge VNet here. And in this remote edge VNet, we have a pair of Aviatrix gateways. These gateways give us the capability of terminating IPsec connectivity in a product we call site to cloud. The advantage of site to cloud is we have multiple encryption options, so we can meet whatever regulatory requirement, whether it's AES 128, 256, etc. And we can also perform source and destination NAT at the same time. So for example, if the university has overlapping IP space in this cloud environment, we can basically NAT it both in the source or the reverse destination direction. It doesn't matter. We can handle your NAT needs there. In addition to this, in addition to the feeds that they're going to bring in, I'd like to call attention here to the bottom left. For their on-prem environment, they had existing express route circuits to the Azure cloud. We can leverage those existing circuits and provide the encryption that's required, which many of you may or may not know. ExpressRoute does not encrypt natively between your on-prem and the cloud. So to help facilitate the encryption and make sure that we meet that requirement, we have a couple of devices called cloud ends that basically function as spoke gateways for us, and we're able to encrypt from an on-prem traditional data center model into our transit. So very excited about that feature. As we discussed, all of the tunnels between our gateways, including that cloud end, are fully encrypted and extremely high speed encryption, as Brian mentioned, right at line rate speed. So we can give you whatever throughput and scalability that you need. We have a solution here for you. As we move from the traffic moving from the feeds through the remote edge VNet, we come down here to our transit. This transit FireNet that we have listed here, this is where we can perform the next gen firewall layer 7 capability type of firewall and inspection. In addition, we can perform segmentation, as you see here, between the remote edge and the PAX VNet. So we can provide multiple options for whatever type of inspection and segmentation needs that you have. One key item I would like to highlight here is that we do have the ability to send only interesting traffic to your Palo Altos or next-gen firewalls, for example. We can only send that interesting traffic to them to reduce load or reduce any type of fees and things that you may be paying for those. It gives you that interesting flexibility and creative options for how you want to route your traffic through your inspection point. And then continuing on to our right here, the traffic's going to flow once again through an encrypted tunnel from the Azure cloud and from the Northern European region to the US East region in AWS for processing. In this particular use case, they had built the application starting in the US East AWS cloud, and they wanted to have the ability for public users or research participants to be able to natively update how they're feeling and some other personalized information. They wanted to allow the customer to update them directly using a web feed. At the same time, over here on the left, the hospitals and universities, they may be using, let's say, a database to upload the information into the application. So this gave us the ability to work with the native CSP resources such as the WAF, as well as provide the remote capability from the hospitals and researchers and integrate it all in the cloud seamlessly for that end user or for that research participant. Once again, showing as we move from the ingestion of data at the remote edge all the way through the AWS cloud, we are able to use native constructs and provide end-to-end encryption for this particular application and for your HLS needs. Also wanted to highlight here, once the data is parked inside of the AWS cloud, they were able to use, once again, native encryption using specific instances that AWS provides. So as the data is moved inside of the VPC, once again, it is still fully encrypted. The last item that Brian mentioned was ThreatIQ, and that was a very interesting request from our customer regarding their ability to see bad actors accessing this remote edge here, as well as looking at data in this completely separate cloud and in a completely separate gateway. To solve this, we use the ThreatIQ product, and we feel like it gives a wonderful visibility to your environment and to what's going on as the data passes through the cloud. So moving over, while I don't have a demo of this actual environment and the data moving through it, we do have in our demo environment, we have ThreatIQ set up on our Copilot product. So what you're looking at here is just a geographical map to start, showing multiple different threats and known bad actors around the world. So from a graphical view, you would be able to see, for example, if you're expecting only data to be coming in from North America and South America, if you start to see, something show up here in the Asia region, it might clue you in, hey, there's something that someone's trying to attack us or someone's trying to investigate, look at our data and give us a data point to investigate here. In addition to the geographical map, as we scroll down here, we give threat severity and threats over time to give you a graphical view of that. But getting down deeper into the data here, we have very specific information, specifically around the source and destination of the information or the known bad actor. So for example, in this particular case, it looks like someone from this 45.146 address has tried to access one of our gateways, and this IP has been flagged as a known bad actor. If we want to dive further into the flow details, we can click on the view icon here. So this source IP has tried to reach out to one of our gateways and has been flagged as a potential known bad actor. We can view this specific threat. We get a visual representation of where the threat was attempted and how it connects in with all of our gateways and our network infrastructure. But jumping over, we can look at very specific flow data. So from a logging and from a forensic standpoint, we can give you some great information here, specifically, date and time, source and destination ports, things of that nature. And then we give you the actual threat information and why it has been deemed a threat in the first place, and gives you a reference of where we received that IP address and why we notated that as a threat to us. Now, let's assume that this is a threat that you are concerned about, and you want to, let's say we want to block this particular address globally or throughout the CSP environment. This is our new Threat Guard feature. And with this Threat Guard feature, it will allow us to create stateful firewall rules that are pushed throughout the environment. So for example, we are saying that anyone, any source IP in the CSP cannot reach out to this known bad actor, this 47.97 address. And as you can see, the action is a forced drop. So this can be pushed out to all of our gateways very quickly, very efficiently. And at that point, all of the exfiltration or potential risk for this particular bad actor has been eliminated. So with that, I think we're coming up on the end of our time. I'm going to stop here and we will move to questions, I believe.
Great. Yeah, thanks, Mac. I think
All
we'll
right.
just to keep track of time here, I think we'll just go ahead and skip the Q&A section for now and go to the next slide, please.
Okay.
Great. Yeah. So for anyone who's interested in learning more about what they saw or having a deeper conversation, architectural conversation on how Aviatrix can help your journey in the cloud, we have a couple of ways to get started. We have something called that we refer to as a sandbox starter, which is a completely automated topology that can be run in just a matter of minutes through Terraform that will build out a multi-cloud network architecture across various cloud providers, and you can start to kick the tires on Aviatrix. In addition to that, we have some architectural design sessions that we make available for customers who are interested with folks like Mac or other folks in our architecture team to really talk about your specific requirements and business initiatives and really dive into the details architecturally. Additionally, we also have the only multi-cloud networking certification that's out there currently. What we refer to that as ACE. There's self-paced and instructor-led classes that are available. And it's a great way to get started from our associate class where you learn a little bit about Aviatrix, as well as the basics and all of the CSPs, all the way up into some of our design experts where we really dive into the solution itself. Next slide, please. In addition, we would love to see you guys on our next couple of tech talks. We have one that's coming up around that's a bit Halloween themed that talks around CSP outages and visibility and how Aviatrix helps with that. In addition, in November, we have a webinar where we will have some folks from GCP joining us to talk about Aviatrix inside of the Google Cloud. Thanks so much for joining today's Tech Talk, and we look forward to seeing you next time.